Since the moment humanity first gazed at the stars and wondered about the universe, one of the most mind-bending mysteries we've struggled to understand has been time. Centuries have passed, yet we still can't fully grasp what time truly is. Most of us imagine time as something that flows forward, an endless river carrying us from the past to the future. But is that really the whole story? Not quite. So, what is time? Is it a real physical thing that exists independently of us, ticking along whether we notice it or not? Or is it simply a human invention, a tool to make sense of change, motion, and the unfolding of events around us? Get ready to be fascinated, because in this video, we'll explore some of the latest and most astonishing scientific discoveries about the nature of time. What researchers are uncovering is both exciting and unsettling, hinting that our everyday understanding of time might be just a small piece of a much deeper cosmic mystery. We'll look at two radically different perspectives. In one, time is nothing more than an illusion, a mental construct our brains create to make sense of reality. In the other, time is fundamental, a real and powerful part of the universe itself. And beyond that, we'll explore daring new theories that suggest time might behave like a physical object with its own properties. The human side of time. It's easy to forget that the way we measure time is entirely human-made. Hours, days, weeks, years, these aren't laws of nature. They're social agreements we use to organize life, to go to school on time, celebrate birthdays once a year, and make sure trains don't collide. Different civilizations throughout history have measured time differently. This alone proves that our timekeeping systems belong to us, not to the universe. But people often confuse this human-made version of time with the deeper physical nature of time itself. Time is a product of change. One popular view is that time exists because things change. The sun rises and sets, clocks tick, atoms move, and our bodies age. Without change, there would be no before or after. In this sense, time isn't an independent thing. It's the result of transformation and motion in the universe. But modern science takes the question further, and things get truly mind-blowing. The emergent view of time. A newer idea called the emergent view of time proposes that time might not exist at all at the deepest level. Instead, it emerges only when countless parts of reality interact, similar to how temperature emerges from trillions of atoms moving together. A single atom doesn't have a temperature, but a cup of hot water does. Likewise, time might not exist at the smallest scales, but appear only when the universe's components interact in complex ways. A 2024 theoretical study even suggests that time itself could be an illusion created by quantum entanglement, the strange connection between particles that instantly influence one another, even across vast distances. According to this research, time appears because of the relationship between a clock system, something that changes regularly, and the rest of the universe. If no such interactions existed, time itself might vanish. At the deepest level, the universe could be timeless, and what we experience as time flowing may just be a story our minds tell to interpret constant change. Time as a fundamental reality. Now let's flip that idea completely. What if time isn't an illusion at all? What if it's real and fundamental, woven into the very fabric of existence? In this view, time is like the stage on which the story of the universe unfolds. Without time, nothing could move, evolve, or exist. Stars wouldn't form. Planets wouldn't orbit. You and I wouldn't age. Einstein's theory of relativity supports this perspective, describing time as a dimension, inseparable from space. Together, they form spacetime, a flexible fabric that bends, stretches, and curves. Gravity, motion, and even the shape of the cosmos depend on how spacetime behaves. Remove time from this equation, and the universe's laws collapse instantly. We also consistently observe something called the arrow of time, the fact that events move in one direction. Broken glass never reassembles. Smoke doesn't return to a matchstick. This irreversible motion suggests there's a deep, physical rule pushing everything forward. The three dimensions of time. In 2025, theorists propose something almost out of science fiction. What if time has not one, but three dimensions? Just as space has length, width, and height, time might also have hidden directions we can't perceive. Imagine time with three axes. X. Indai, we prime der ender rasen den der z. Moving in the X direction feels like our normal experience. Past, present, future. The Y direction could represent alternate outcomes, different versions of the same moment. and the z direction might capture internal time, memory, consciousness, or perception. If we could somehow move sideways in time, we might explore alternate versions of a day without moving forward or backward at all. Quantum particles, in their strange superposition state, might already be doing this, exploring different directions in time before settling into one. If true, it would mean our experience of a single arrow of time is just a shadow of a much larger multidimensional structure. Time as a property of matter. Another bold concept known as assembly theory suggests that time isn't something we move through, it's something that grows within things. The more complex an object is, the deeper it sits in time. A rock is simple, with a low assembly number. A living cell, shaped by billions of years of evolution, has a much higher one. In this view, the universe isn't just expanding in space, it's also expanding in time, as complexity increases. Time becomes a physical quantity embedded in matter itself. The discrete frame theory. Some scientists propose that time might not flow smoothly at all. Instead, it could be made up of tiny discrete frames, like the individual frames of a movie. At the quantum level, each frame represents a distinct slice of reality. The flow of time, we feel, is an illusion caused by countless microscopic jumps between frames. If the universe really runs this way, its frame rate might even change near extreme environments like black holes, where time slows or stretches. Quantum time and negative duration. Recent experiments have revealed even stranger behaviors. In certain quantum systems, the direction of time isn't fixed. Processes can unfold both forward and backward depending on how particles interact. In another study, researchers found evidence of negative time, where light interacting with atoms seemed to happen before the cause. It doesn't break physics, it simply shows that our normal sense of cause and effect doesn't apply perfectly at quantum scales. At these levels, time becomes fluid, twisted, looped, and unpredictable. The great mystery. When viewed up close, time isn't a simple smooth river. It's more like a vast turbulent ocean, full of hidden waves, loops, and currents. At our everyday scale, time feels stable, constant, and irreversible, but deep beneath that surface, it may behave in ways we can barely imagine. We've built clocks that can measure time with extraordinary precision, yet physicists still don't fully understand what time is. One thing is clear, we've only just begun to uncover its secrets. Time might have hidden rules, hidden directions, even hidden structures, waiting to be discovered, and the more we learn, the more time itself seems to defy us.